Well, hello everyone, I'm Aram Khanlari and welcome to my YouTube channel. In this series of videos, I'm going to talk about computer science and I'm going to make tutorials to help you guys with programming. I'm definitely not going to do this because my professor asked me to or because this was my home assignment. Duh! Okay, so where do we start? I don't know. I'm kidding, of course. We're going to talk about computer science. What is computer science? It consists of two words, computer and science. Duh! So the first word, computers, what are they? They're basically everywhere, anywhere we go. Our TV is a computer, our phones are computers, our personal computers are computers, of course. So they've conquered all over the world. Second word, science. It's basically a study of life, when a bunch of people gather around, do some research, and they discover some things new, and it's cool, right? Makes sense. So today we're gonna start with what every science starts with. For chemistry, it's atoms, for mathematics, it's numbers, and etc. Well, it turns out that for computer science, it's the basic numeric system computer science uses for its fundamentals. Let's call our whiteboard for the help. So for mathematics, we use 1, 2, 3, and etc. for counting. Right? For computer science, we're going to use only two numbers, which is either 0 or 1 to count. So 0 or 1. So this system is called binary system. Bi means 2. It's a coincidence that it starts with B, which is the second letter of alphabet. So with the help of these two numbers, we indicate if something's there or not. We can also use these numbers and combinations of them to count as we do regularly. 1, 2, 3, and etc. To see how it's done, let's make everything we just wrote on the whiteboard magically disappear. So, the ancestors of computer science have decided that 0 is 0. 1 is 1. Then what else? We can combine 1 with 0, and this will mean 2. We go on with 1 and 1, so 1, 0 plus 1, and we get a 3. With me so far? So next we go on with 3 digits. That's 1, 0, 0, and it makes a 4. Then we add 1 to 1, 0, 0, and we get 1, 0, 1, which is 1 plus 4, 5. After that, we add 1, 0 to 1, 0, 0, and we get 1, 1, 0, which is 2 plus 4, and it equals 6. So what's the last combination? It's 1, 1, 1. And it's 1, 0, 0 plus 1, 0 plus 1, which is 7. Am I right? So this can go on forever and ever and happily ever after, but the only thing increasing we have here is the number of digits. So here we have only 1 digit, then we have 2, then we have 3, and it goes on and on. That just like regular numbers. We have from 1 to 9, we have 1-digit numbers. From 10 to 99, we have 2-digit numbers. From 100 to 999, we have 3-digit numbers, and on and on. So let's try to see how many numbers do we have. So it goes from 1 to 9, we have 10 numbers. From 10 to 99, we have 90 numbers. From 100 to 999, we have 900, then it goes 9,000, then it goes furthermore. So from 1 to 99, we have 10 plus 90, which is 100 numbers. And from 1 to 999 we have 1000, and then 10,000, and furthermore. So do you see a pattern here? I do. This goes 10 with the power of 1, then 10 with the power of 2, 10 with the power of 3, and furthermore 10 with the power of 4. This goes on and on. So this is the decimal system. Des means 10 in Spanish, probably. Saw the power thingy with the decimals, right? So we can go with this with the binary system. So we have two numbers here which have one digit. So it goes like this. We have two more numbers that have two digits, which is 2 times 1 plus 2, which is 2 squared, 4. So we have four more numbers which have three digits. So it gives us 8 combinations, which is 2 cubed. And it goes on and on. So we can see that 3 digits have 2 power to 3. Do you get it? Okay, so now since we know that every number is representable by the binary form, we can try to do some exercises. So let's get rid of this. And just randomly write a number. 1. Okay, this doesn't seem hard. Let's try to do this. So to help us do the math, we're going to write the powers of 2 here. So it starts with 0, goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here we have ones, right? So can we say that this number is 2 times 1? So is this true? Of course it is. So we can write 2 here. So the next thing we know is that this is 4, right? 1, 0, 0 in the binary system means 4. So, and 1, 0 is 2. So 1, 1, 0 is 6. So we can replace all this with 6, right?
Mm-hmm.
So what does this number equal to? So we go 1, 0, 1, 1, 0. We already know that this is 6, and we know that this is 2 power to 4. So this is 16. So this is 16 plus 6, which means 22. So we can replace all this with 22. So this, it means 2 to the power of 6, which means 64. So this is 64 and this is 22. So we can replace all this with 86, with the sum of them. And last but not least, this one here, it represents 2 to the power of 10, which is 1024. So we get 1024 plus 86 is 1110. Easy peasy. Okay, so let's try concluding this. So what we have learned today is the fundamentals of the binary system. And I want to raise 2 important questions. First of them is, do we need systems in our lives? Systems. And the second question is, just like binary numbers, is everything in life in life? 1 or 0? Okay, so these two questions are just food for thought. You can answer them in the comments below. You can make a discussion. And if you liked my video, put a thumbs up and subscribe to my channel. And I'll be back next time with another video. See ya, love ya, bye!